The Yarkovsky Effect, Sunlight's Sneaky Influence on Asteroids. Hello and welcome to our channel, where we explore the mysteries of space and the wonders of our universe. Today, we're exploring an interesting phenomenon known as the Yarkovsky Effect, the sneaky influence that sunlight has on asteroids. The Yarkovsky effect is a fascinating phenomenon that has been gaining attention in recent years due to its potential impact on planetary defense and space exploration. This effect refers to the subtle but significant influence that sunlight has on the movement of asteroids in space. Although the effect was first proposed over a century ago by the Russian engineer Ivan Yarkovsky, it has only been in the last few decades that scientists have been able to observe and measure it directly. In this article, we will explore the science behind the Yarkovsky effect, its impact on asteroid movement, and its implications for future space missions and planetary defense. Introduction to the Yarkovsky effect. What is the Yarkovsky effect? The Yarkovsky effect is a phenomenon in which the rotation of an asteroid can be influenced by sunlight. As an asteroid orbits the Sun, it absorbs sunlight and then radiates that energy back into space as heat. This release of energy creates a tiny amount of thrust that can alter the asteroid's trajectory over time. History of the Yarkovsky effect. The Yarkovsky effect was first proposed in the late 19th century by a Russian engineer named Ivan Yarkovsky. However, it wasn't until the 20th century that astronomers began to realize the full extent of its influence on asteroids. Scientists now believe that the Yarkovsky effect plays a significant role in the dynamics of the asteroid belt. Understanding the science behind the Yarkovsky effect. How does the Yarkovsky effect work? The Yarkovsky effect is caused by a slight unevenness in the way an asteroid absorbs and radiates sunlight. When sunlight heats up one side of the asteroid, that heat is eventually released on the opposite side, creating a small but consistent force that can alter the asteroid's orbit over time. The role of thermal radiation in the Yarkovsky effect. The Yarkovsky effect is driven by thermal radiation, which is the process by which objects release energy in the form of heat. As an asteroid rotates through space, its temperature fluctuates based on the amount of sunlight it is receiving. This temperature change creates a thermal gradient that results in the release of energy and, ultimately, the Yarkovsky effect. The impact of sunlight on asteroid movement. How does sunlight affect asteroid movement? Sunlight plays a significant role in the movement of asteroids. The Yarkovsky effect alters the asteroid's orbit in such a way that it can potentially collide with other objects in space. Asteroids that are affected by the Yarkovsky effect can also drift farther away from the Sun, or closer to it, which can ultimately impact their chances of colliding with Earth. Examples of asteroids affected by Yarkovsky effect. One example of an asteroid affected by the Yarkovsky effect is Apophis, which was discovered in 2004. Scientists have predicted that Apophis will pass dangerously close to Earth in 2029. But have also calculated the asteroid's trajectory over the next century to determine that it will not collide with Earth thanks to the Yarkovsky effect. Importance of Yarkovsky effect in planetary defense. Why is the Yarkovsky effect important for planetary defense? The Yarkovsky effect has important implications for planetary defense because it can alter the trajectory of an asteroid and potentially prevent it from colliding with Earth. By understanding the Yarkovsky effect, scientists can better predict the movement and potential impact of near-Earth asteroids. How can we use the Yarkovsky effect to our advantage? Scientists have proposed using the Yarkovsky effect to nudge asteroids away from Earth. One proposed method involves launching a spacecraft to land on an asteroid and alter its trajectory using a small but powerful rocket. By taking advantage of the Yarkovsky effect, scientists can potentially deflect an asteroid from colliding with Earth and prevent a catastrophic impact. Observing and measuring the Yarkovsky effect. The Yarkovsky effect may be a sneaky force, but it is still measurable and observable using a variety of tools and techniques. One of the most common ways to observe the effect is through studying the asteroid's rotation rate and changes in its orbit over time. This can be done using telescopes on Earth, as well as by spacecraft that have been sent to study asteroids up close. Tools and techniques for observing the Yarkovsky effect. In addition to observing the asteroid's orbit and rotation, other tools and techniques have been used to study the Yarkovsky effect. For example, scientists have used thermal imaging to measure the asteroid's temperature and how it changes over time as it rotates and moves through space. This allows them to track the heat emitted by the asteroid and the direction in which it is being pushed by the Yarkovsky effect. Challenges of measuring the Yarkovsky effect. Measuring the Yarkovsky effect is not without its challenges. For one, the force is extremely small, which means that even small errors in measurements can make it difficult to detect. Additionally, it can be challenging to separate the Yarkovsky effect from other forces affecting an asteroid's orbit, such as gravitational interactions with other objects in the solar system. Implications for future asteroid missions. Understanding the Yarkovsky effect can have important implications for future asteroid missions. By taking advantage of this force, scientists and engineers may be able to improve spacecraft navigation and reduce the fuel needed for missions. How can we use the Yarkovsky effect to improve asteroid missions? One way to use the Yarkovsky effect is to direct a spacecraft towards an asteroid in such a way that the force boosts its velocity and helps it reach its destination. This could potentially reduce the amount of fuel needed for the mission and make it more efficient. Additionally, by studying the way the Yarkovsky effect changes an asteroid's orbit, scientists may be able to better predict its future trajectory and avoid potential collisions with Earth. Opportunities and challenges in exploring the Yarkovsky effect for future missions. While the Yarkovsky effect presents exciting opportunities for future missions, there are also many challenges to overcome. For example, accurately measuring the force and understanding how it affects an asteroid's orbit requires detailed observations and calculations. Additionally, spacecraft must be designed with the Yarkovsky effect in mind, which may require new technology and engineering solutions. Conclusion and future research directions. The Yarkovsky effect may be a subtle force, but it plays an important role in shaping the paths of asteroids as they move through space. By studying and understanding this effect, we can improve our ability to navigate and explore asteroids, as well as better predict potential hazards to Earth. Summary of the Yarkovsky effect and its importance. The Yarkovsky effect is a force that affects the orbit of asteroids by causing them to slowly move away from the Sun over time. This can have important implications for future asteroid missions, as understanding and using this force can potentially reduce the amount of fuel needed and improve spacecraft navigation. Future research directions in understanding and using the Yarkovsky effect. Future research on the Yarkovsky effect may focus on improving our ability to measure and observe this force, as well as developing new technologies and engineering solutions to take advantage of it. Additionally, by studying the Yarkovsky effect on different asteroids, we can better understand how it varies across different types of objects in the solar system. In conclusion, the Yarkovsky effect reveals the powerful impact that even the smallest forces can have on the movement of objects in space. As we continue to explore the mysteries of the universe, understanding and harnessing this effect will be crucial for improving our technology and capability for space exploration and planetary defense. With continued research and innovation, we may one day be able to fully utilize the power of the Yarkovsky effect for the betterment of humanity. Overall, the Yarkovsky effect is just one example of the many forces at play in our solar system. By continuing to explore and understand these complex phenomena, we can gain a deeper appreciation for the incredible wonders of our universe and the amazing science that helps us study them. We hope you've enjoyed learning about the Yarkovsky effect with us today, and we look forward to sharing more exciting educational content with you in the future. Thank you for joining with us. Thanks for watching.